Hi friends, today we are going to do one more interesting topic. So the tutorial will be about how do we deploy a Python AI web service that uses simple iris dataset to Kubernetes cluster in Google Cloud. So earlier we did a tutorial where we mentioned how we could deploy such a Python AI web service to AWS EC2. Today we'll see how we can deploy it to a Google Cloud cluster. So as you can see, this is the Python IPNB file which creates a model using the load iris dataset. We import all the libraries uh, and we load the iris dataset. The iris dataset is a basic dataset that contains the flower data which has petal length, petal width, sepal width, and it predicts the target species of the plant. So right now we have divided the data into feature data and the target data. Uh, Now we'll split the data into training and testing data in the ratio of 70:30. We'll use a basic supervised AI algorithm called KNN, K nearest neighbor classifier, which uses the distance between the nearest neighbors. Here we are considering the nearest neighbors value as 2. That means the two of the nearest neighbors will be considered when classifying the category. And then the weight is distance. By default, it defaults to the Euclidean distance, which is like when we have two values or set of a vector with set of points or distances between two different points. Each point is denoted by a xi, yi location, and this particular data is used to calculate the weights. So the formula would be the summation of xi minus yi, where I is 1 to n and to the power of p, and then the summation is uh, inverse to the power of 1 by p. So here if the p is 2, then it is Euclidean distance. That is what it is defaulting to this time. If it is 1, it is Manhattan distance, and this formula is called Minkowski formula. Now we fit the data to our model and then we predict the category of the species. Now we also display the accuracy, as you can see, and then we predict the target species as well using a iris dataset has a array that lists the category name by using the numerical prediction value. So this is the model. We will pickle the model, and we can give any name. The .pkl file can be named to any other extension, but this is just a convention that we follow. Now we put this file in our in a sample project, web service project, and this is our code that has the um, pickling code. And then we have a web service. We are using Bottle library framework. We could use any other framework as well, but I'm comfortable with Bottle, and we could use Flask as well. So we import all the necessary libraries. We create a Bottle instance, and then the configuration is loaded from application.properties file. You can load it based on the environment by using a Docker environment specific Docker file. You can load any environment specific application. Right now we are not using any particular environmental properties, so this is just for depiction. So next we are going to have a basic health check, which is a get service, and then we have a post web service. We are loading the model in the body of this particular Python file, and then because this is common across all the methods, this will be loaded when the application web service is loaded in upfront. And then this is the post web service call. This is the one that will take the post data, which contains the petal length, sepal length, and petal width and sepal width, and it predicts the predicts the actual category of the species. And then as earlier, we use the target names array to print out the actual categorical value, and we wrap it nicely in HTTP response with the 200 response code, which means successful. And then we use JSON to make it end user friendly. So, and then we in the main method we set the log level. We could do some common items and we serve up the bottle application at port 8080. Now let's go to the Docker file, and this is where we load all the dependencies. We could use a requirements file, but here because it's a simple application, I'm just using the run command and installing the Boto, bottle, pyaml, waitress. We don't need Boto, but if you want to put it in a Lambda, AWS Lambda function, you could use Boto, but right now we don't need it. Um, so you don't need to run that particular. You can install bottle, pyaml, waitress, url lib, and dateutil, etc. And we are doing some basic things, like once we download the Docker container from Hypercube. I'm using Hypercube. You could use any other image. This is a Red Hat images repository. Once I download it, I'm updating the Python to version 3 and the pip, and also uh, I'm installing upgrading pip. I copy all the items that are there in the src folder. As you can see, I have other files. You don't need the SQL queries. In case you connect to a database, you could use that, but right now I'm not doing all those things. Just copy whatever you have in the src folder, and then you add a basic Docker user and you expose the web service at port 8080. So that's it. And then let's build a Docker image. Let's go over Docker thing, and then I have already built a Docker image just now. So let's see. So I'm using this command docker build -t. This is the name of my Docker image. Now what I'm gonna do is we need Google Cloud command line tool, so that we can upload this image to a Google Cloud container registry. Earlier, if you remember in our AWS tutorial, I mentioned how you don't need to use a container registry. You could just um, check it into Git and you can download it from Git on your EC2. Here I'm doing it in a different way so that you get the best of both worlds. I installed Google Cloud for my Mac. Once you install Google Cloud, you just have to go to the Google Cloud download page, and they will guide you. You can download the DML file based upon your operating system, that is Windows. I have a Mac, so I have downloaded the DML file. Um, the Mac specific file, and I installed it, but you need to set the path in your bash profile. So bash profile is a file where on Mac where you set the class path to your executables for the applications that you want to be available in your runtime. So here, as you can see, I exported the path to my Google Cloud downloaded SDK, and I am appending the path so that we don't lose the previous set paths, like we have Anaconda and other things that I have set. So I have already set it. You need to refresh your bash uh, profile before you do that. Uh, so you could use the source command. Otherwise, you will need to restart bash. So now if you see, you should get something at the command prompt. Yeah, so you have this set in your class path. The tool is available. So now what we are going to do, we already build a Docker image. We need to tag it. I already had a tag 001. So now I will just use 002, but before that we need to log in into Google Auth. So it opens a login page. You just have to choose which login is you're using to use Google Cloud tool. So it says you are authenticated, and then I need to configure my Docker. So it already configured my Docker. So let me see what it added. As you can see, it added certain items to my Docker file so that I can get authenticated whenever I want to use my Google Cloud resources. So once you are done, you could tag your Docker application. I'm using 002 now. So let's check the Docker images. Yeah, as you can see, there is a Google Cloud Docker image and has a tag 002. Now I'm gonna push this to Google Cloud. So before that, let me show you my Google Cloud. If you have any tags, let's go to container registry. So let's go to the container registry. Container registry is nothing but a place we could use to store the Docker images. It's a easier way, it's a more modular way. When you go to production deployments, the DevOps person can directly get the image from this particular repository, which the developers check in the final image and he can use it. So we have 001. Let's refresh it. So now we are going to publish the 002 to the Docker repo. So we do that. How do we do that? We do that using the Docker push command. And you must be wondering how is the authentication. We use Google authentication. You must be familiar with this. It just opens up your Google login and you need to log into it. I was already logged in, so it's opened up a successful login page. So if you are not yet logged in using your Google ID, then it will ask you to enter your credentials. So this time it did not ask me because I have already entered my credentials for my earlier attempt. So right now, as you can see, it is pushing the Google Docker image into my Google container registry. So shortly we should see the 002 tag of my Python web service AI application in this registry. So let's wait a bit. It's going to take a while. In the meantime, let's go to our dashboard. Let's check the Kubernetes engine. See, I have already created a Kubernetes cluster in the Google Cloud console, and right now it is empty. So how do I find out? Like if I go to workloads, I have not deployed anything using that, so it shows a empty workloads folder. If I have already deployed something, it would list the set of deployments. So I have an empty cluster that I have on my Kubernetes console. So we will use this cluster to deploy our web application. And guys, Kubernetes is a container orchestration tool, the framework or tool that will help to deploy the application, automate the deployment of an application, the maintenance in the sense the auto scaling of the application. It could do both horizontal or vertical. I think by default it is horizontal auto scaling. Horizontal is basically it will increase the number of nodes and vertical is in each node the computing power it will increase. So right now I think it will default to the horizontal auto scaling, and then it will also do various things like it checks it provides logs for you, and monitoring services using a plugin called Prometheus. So it does all that for you. So you get alerts, you can configure it to send alerts to you whenever there are errors, or some out of memory issues. It could do several things. That's why it is called a container orchestration framework. So it will make it easy for you to deploy your applications. So let's go back to our console and see, yeah, the image has been pushed. So we need to check in our container registry if the image exists. So let's go and check. As you can see, we have a latest image. So now we will go back to our Kubernetes engine, and we will click deploy button. So we will use the container registry to select our 002 Docker image, which is the latest version. We don't have any environment variables, and then we'll just name our application as iris hyphen docker hyphen iris hyphen docker. Okay, if you want YAML configuration, you can also upload it, but right now it's a simple application. We can use YAML files to do that, but right now we are not using that. And this is our single cluster. It is deployed at US Central location. I think it will create 3 nodes, and each node will have a pod, and each pod will have a container that holds our application. Right now we have a single container or single application that will run on all the pods, on each pod of each of these nodes. So there will be 3 nodes. So let's deploy. And you might ask, well, where did you configure these 3? I just selected the default Kubernetes engine. I think that created the set of 3 nodes in its default location. So this is going to take a while, friends. You just have to wait a bit. So this is called a autopilot cluster. You can define your own cluster, but for simplicity's sake, I just choose the default one, which is called the autopilot cluster. So once that application is deployed on the cluster and the compute instances are created within the Kubernetes pods, we will use this particular curl command to invoke the predict endpoint. We will pass on the post data, which is the petal length, sepal length, petal width, and sepal width, and in response we should get a category of that particular species. This IP address is the IP address of the load balancer. In short, very soon we are going to see how this particular IP address is given to us. So it has deployed the Docker image into our Kubernetes cluster. See, there are three pods. I think it has three pods, and on three compute instances. Let's go ahead and see what is there on each pod. See, this is one container. Let's go back. So go to the workloads. And we have three pods now. We need to click the expose button to expose it to a public internet. So by default, it has a port 8080. It will accept the traffic. It's the ingress for it. And so this is where the internal container accepts the traffic as well. So we'll put it as 8080 as well, because in our application we have, if you remember, we have exposed it at 8080. So if you want, we'll view the YAML. So this is the YAML representation of the resources that we are going to deploy. And once we click expose, it will create the load balancer with external IP address, and that is what we are going to use to invoke our web service. So this is again going to take a while. We just have to wait a bit. So as you can see, the external endpoint is defined at this particular IP address. Let's see if we are able to hit the health endpoint, which is a basic get web service. We'll just refresh it. I think there is something wrong. Let's figure it out. Go to the workloads. This is the previous one I created, so let me refer that to see what went wrong. We'll just delete it and we'll create a new one. Okay, let's go to the workloads. To our workload. I think we'll click on the expose button again. We'll add one more port. Get port is 8080. One port is 8080. We'll click expose. So now let's use the external service, load balancing public IP address to check if our application is available. So as you can see, whatever health check we have, that seems to work because it's returning okay. Now we are going to go back, use this IP address to post to our prediction endpoint. So at this point, we have deployed our web application, the Python web service that predicts the iris dataset using the more pickled model. And now we are going to go and we are going to post the data to our deployed web service. As you can see, the target flower, the target category is being displayed in a proper JSON format. So we have successfully deployed our web application, Python web service to Kubernetes, Google Cloud. So that's about it, my friends, for today. I'll come back with one another interesting tutorial. Until then, goodbye, subscribe to my channel, and adios.